So now that I showed you long division, I'm going to show you synthetic division, and there may be some grumbling and complaining because this is much easier. Now, the downside to synthetic is that you can only use it when you divide by x minus c, or you could say, it could be x plus something or minus some c value. So it's got to be simple. You can't have something like this and use synthetic division. So here's how you do it. Only the coefficients. I put this box over here, and I'm going to use this 1, 3, negative 13, and 6. Now, remember that this is representing the constant, the linear, the quadratic, the cubic. No x, x squared, x cubed, and so if you're missing any one of these, you have to put a 0 in place of it. And over here, I'm going to put positive 2. This is standing for the root. Remember that if x minus 2 is what we're dividing by, x minus 2 equals 0, x equals 2 is the root. Notice, not negative here. Opposite of what you think. So it's the opposite of the factor. Okay, so drop the 1 down. And now we do 1 times. So you add going down, and you multiply going this way. So 1 times 2 is 2, and we put that there. 3 plus 2 is 5. We put that there. 5 times 2 is 10. Negative 13 plus 10, negative 3. Negative 3 times 2, negative 6. 6 plus negative 6 is 0. That is our remainder, or lack thereof. So, what does this and this and this stand for? Well, we just took x cubed and divided by x. So, we're going to get an x squared. I always like to work backwards. This is our constant, this is our x, and this is our x squared. So our answer is x squared plus 5x minus 3. And there you have it. Okay, so now you try. Again, if we're dividing by x minus 2, we put a positive 2. X minus 3, I put a positive 3. If this was plus 3, I would put a negative 3 there. So 2, negative 4, negative 7, and 5. Drop down the 2. 2 times 3 is 6. Negative 4 plus 6 is 2. 2 times 3 is 6. Negative 7 plus 6 is negative 1. Negative 1 times 3 is negative 3. And 2. So 2 is our remainder. So this is our constant, this is our x, and this is our x squared. So our answer is 2x squared plus 2x minus 1, and plus our remainder over what we couldn't divide by, our x minus 3. Okay, now for the next level up. This 4x minus 7, if I put this equal to 0, x is add 7, divide by 4. So I'm going to use 7/4. So I'm going to use 7/4 in our little box over here. And I'm going to use 8, 2, no x, so I have to put a 0, and a negative 49. So, drop down the 8. Some of this will be the bane of your existence because we're working with fractions. So 8 times 7/4. I'm going to put that off to the side. 8 times 7/4. 2 and 1, so 2 times 7 is 14. So 2 times 14, adding going down, 16. 16 times 7/4. That's 4 times 7, because this cancels out, it's 4, so we get 28. 0 plus 28 is 28. 28 times 7/4. If we cancel out the 4, that leaves a 7. 7 times 7 is 49, and you get 0. This is our constant term. So again, 4x minus 7 must be a factor because it's a remainder of 0. So this is 28, our constant, x squared. Fill it in from the back. Again, we took this and divided it by x. So we got 8x squared plus 16x plus 28. Now the only problem with doing synthetic, be very cautious, is that when you do 8x to the third divided by 4, you would think that you would come up with a 2 something, and you would be right. So the last thing we have to do is divide by that 4. So because we haven't taken it into account. So 8 divided by 4 is 2, not 4. 2x squared plus 4x, 28 divided by 4 is 7. And now, if you multiply this by 4x minus 7, notice how you get 7 times negative 7, you get negative 49, and so on. So you'd be in good shape. Okay, so now remainder and factor theorems. You've pretty much already talked about it, but it's pretty slick. So evaluate the polynomial f of x when x is negative 5. So up until this point, you would just take this negative 5 and plug it in, and that still works. F of negative 5 is negative 5 cubed plus 4 times negative 5 squared minus 8 times negative 5 minus 6. So that's negative 125 plus 4 times 25, that's plus 40 minus 6. So that's negative 125 plus 100, negative 25. So you get 9. So f of negative 5 is 9. Now, you can imagine as these get longer, well, there's just another way you can do it. We can use synthetic substitution. And so what I mean by this is we put negative 5 in our corner. Notice that this is not opposite. Because this is the x value. X equals negative 5, where before it was the factor. And so then we're taking the 1, we're taking the 4, we're taking the negative 8, and we're taking the negative 6. Drop the 1 down. 1. Negative 5. Add negative 1 times 5. Negative 3. Negative 3 is 15. 15 minus 6, or negative 6 plus 15 is 9. Notice, 9 and 9. That is the remainder theorem. So the remainder theorem says remainder after dividing f of x by x minus some number, a, in this case x minus a negative 5, x plus 5, is f of a, f of negative 5. So after dividing by x plus 5, because I divided by x plus 5 here by putting the negative 5 there, I got 9 as my remainder, and that's the same as if I had just plugged in negative 5. Here's why it's beneficial. 2 ways you can do it. Is x minus 2 a factor of this? Well, you can do synthetic division, or it works the other way with knowing if it's a factor. You could plug in 2, or is x equals 2 a 0? Do we get 0 as a remainder? Do we get 0 when we plug it in? Because if x minus 2 is a factor, 2 is a 0, or other words a root, or other words an x-intercept. So plug in 2. 2 to the 4th minus 4 times 2 cubed plus 5 times 2 squared plus 4 times 2 minus 12. 16 minus 4 times 8 plus 5 times 4 plus 8 minus 12. Yes, x minus 2 is a factor. Or the other way you could do it is you could actually see, you could divide. You could plug in 2, you could do 1, negative 4, 5, 4, negative 12 with synthetic division, right? Pulling these numbers out. Drop the 1. 1 times 2 is 2. Add them together. Multiply. Add them together. Multiply. Add them together, multiply, and we get 0. So either way, x minus 2 is a factor. But it's essential on this one that you know this method, because if you tried to do synthetic division with this one, you'd have to leave zeros for x to the 99th, 98th, 97th, and so on. So is x minus 1 a factor? Well, f of 1 is x equals 1 a root is the question I'm answering. So 1 to the 100th plus 1 to the 90th plus 1 to the 80th minus 3. 1 plus 1 plus 1 minus 3. So it's 0. Yes, x minus 1 is a factor. Okay.